Okay. So we're going to look at this example. We have a graph and we have a set of values in a table, and we're going to determine if they have positive correlation, negative correlation, or no correlation. So remember that we said correlation is similar to slope. So when I look at the first example, it's a graph. Do you feel like that graph represents positive correlation, negative correlation, or no correlation? Yeah, it's positive. I don't know who said that, but it's correct. This is positive correlation. We can see that the line, as we read the graph from left to right, we can see that the line goes up, much like positive slope. But what about the table? Evan, how did you determine that? So as y gets bigger, plus 3, plus 9, plus 3, plus 2. As y gets bigger, x is getting smaller. So if I were to graph that, as the y values get bigger, the x values get smaller. So it would look something like this. Okay, just think about it in terms of slope. You would have 3 over negative 1, or 9 over negative 1, or 3 over negative 1, right? So because that x value is getting smaller, that's a negative. So you're going to have negative correlation. Does that make sense? Okay. What if the x values were increasing, but the y values were getting smaller? What kind of correlation would that have? What if the x values were increasing, but the y values were getting smaller? What kind?
Positive.
What is negative 3 over positive 1? Negative. So let me say again. I want you to understand what I just asked you. So we know that this has negative correlation because as x gets smaller, y gets bigger. So that's going to be a negative. X is getting smaller, meaning it's negative. Y is getting bigger, it's positive. That's what this graph shows. Y is getting bigger, y is getting bigger, x is getting smaller. X is getting smaller. So my question is, what if x gets bigger and y gets smaller? What kind of correlation is that? Say it again, Namely. It's negative because x is getting bigger plus, but y is getting smaller. A positive divided by a negative is a negative. A negative divided by a positive is a negative. Okay? So let's talk about when you have positive correlation. You have positive correlation when as x increases, y increases. Right? Or as x decreases, y decreases. Why is the second one true? Why is it true? That just doesn't even make any sense. As x gets smaller, y gets smaller, that's positive correlation. Well, if x is getting smaller, that means that that means if I look at a table, I'm subtracting, right? Yes or no? And if y is getting smaller, that means I'm also subtracting from a table. What is a negative divided by a negative? That's why. Okay. So does that kind of make sense? Because that's helpful when you look at a table. All right, let's practice matching some situations. So we're going to match each graph 1, 2, and 3, to the scenarios in A, B, and C. So let's talk about the graphs first. In graph number 1, I can see that as x gets bigger, y gets bigger. This has positive correlation. Do you guys see that? In graph number 2, it looks like as X gets bigger, Y is getting smaller. So this is going to be negative correlation. And in graph number 3, what do you see there? No correlation at all. Okay. So let's read the scenarios and see if we can come up with a match. So the number of trucks on the road and the number of days in a month. Let's think about that for a second. What about the time spent driving compared to the distance that you travel? Or the number of months you own a car and the value of a car? Macy. The first one, A, like the first graph, you mean, is B? Yes, the first graph is B. The time that you spend driving and the distance, there's a correlation. The longer you drive, the farther you go. That makes sense. What do you got for us, Sailor? Yeah. This is the number of months that you own your car, and this is the value of your car. The older your car is, the less valuable it is, right? Okay. What about the number of trucks on the road and the days in the month? Does that have? Yeah, it doesn't have anything to do with anything. Like it's like the number of students at the football game compared to what I'm serving at Floyd's. Like, it has nothing to do with each other, right? Okay. Questions about that? Okay. So correlation coefficient, this is what I talked about earlier in our warm-up, the R. So the closer that R is to 1, meaning positive correlation, or -1, negative correlation, the more closely the data points represent a nice straight line. So we use what's called a line of best fit or a trend line to approximate scatter plots. We kind of group the data together and we try to fit a line in the middle of the data, and that's called a trend line or a line of regression. So we are going to start practicing doing that in Desmos. So it says the strength of a linear regression is reflected by the value of the correlation coefficient. So much like I did I'm going to shrink this up a little bit so I can talk about all of them. Much like I did in our warm-up, you can see that the first one has basically negative correlation, but I can literally put a ruler up there and connect all the points. So that has a correlation of -1. The second one, I can almost connect all of the points. So maybe that's like a -0.8 or a 0.9. The third one, 0.5, like we did in our example on the board for our warm-up. It's like a -0.5, still negative correlation, but not as tightly. And then the last one, kind of like a snowstorm, no correlation, okay? So we're going to look at correlation today in terms of calculating. So let's go to this matching activity, the next thing in your notes, and then I'm going to show you guys how to build data. We're going to do Desmos today, and then tomorrow we'll practice building data in a calculator because it's a mess. And when you take your end of course assessment, you guys don't call it an ECA, you call it a EOC, right? Isn't it called EOCs here? Okay, so when we take our EOC, we use Desmos. So as long as we know how to do it, and that will be good. So we're going to match the graphs with the correlation coefficients at the bottom. So let's talk about this first graph right here. Courtney, what kind of correlation coefficient do you think that has? Is it positive or is it negative? That's the first thing I'd look at. And then do you think it's closer to -1, positive 0.7, positive 1? These are your correlation coefficients down here. So you think that the first graph match? That's okay. I didn't hear you. Say again. Yeah, so I want you to look at this graph right here. And tell me which R does it match? Which R do you think it matches? Yeah, this has a correlation coefficient of negative 0.7. I know that it's negative, right? I can see that the line is going down, but it's not a nice, like, connect the dots point line. It's not nice and tight like a -1. What about this graph right here, the next graph? What do you think that correlation is, Miles? What's the R value? Nope, of this top right one. R equals 1. I agree. Okay. Staley, let's look at this graph right here with the little orange asterisk. What do you think the correlation coefficient of that is? R equals 0.7. And the last one, Isaiah, the last graph. R equals -1. Does this make sense? Okay, remember, it's just basically slope. Okay. All right. So a line of best fit or a trend line is a line that resembles data from a scatter plot. So remember that scatter plots are bivariate. So I'm going to put two variables up here because that's what the data is. It's two variable data. So it's just a line that closely resembles the data from a scatter plot. Shopping cart, very cool. Okay, so I am going to ask you guys to open your Chromebooks, and if you, yes, ma'am. I'm so sorry, yes. Open your Chromebooks, and I want you to go to Desmos. I'm going to spell that because maybe I don't say it the way it sounds. Desmos Graphing. You're so welcome. Go to Desmos Graphing. And we are going to learn how to create scatter plots in Desmos. The reason that we're going to use Desmos is because A, again, that's what your EOC is going to require to use. And B, you don't all have scientific or graphing calculators at home. Does that make sense? So if we don't finish our homework in class today, you're going to need to know how to do this, right? Okay. So we're going to start with this data set, but we're all going to go to Desmos. So I'm going to pull up my Desmos screen that I have right here. Okay. So everybody should be in a screen that looks like this. I have to pull this down a little bit because, I have to pull it down a little bit so you can see the top. All right. So does everybody see this little plus button here in Desmos? I want you to click that plus, and we're going to click on the table because our data is presented to us as a table. Do you see that? So in your data set right here, example number 3, we have oil changes and cost of repairs. X is the number of oil changes. Y is the cost of repairs. Does everybody see that from our notes? Okay. I don't have that projected. So you're going to have to look at your notes as we input the data set because I want to show you what's going on here. So I just build the ordered pairs. Our first ordered pair is 300. And then hit the enter key. Your next ordered pair is 300. What period is she supposed to do that? Okay. So I have her for period 3, and I have a really stern conversation with her. Okay. Okay. You're awesome. Thank you, ma'am. Bye. Okay. So build your data set. Does everyone see what you're doing? You're like creating your ordered pairs from your notes. You're inputting this data set. You're inputting this data set. You can probably do it faster. You're inputting these. These are your X's, these are your Y's. Does everybody see it? These are your X's, these are your Y's. Yep. Holy cow, Michaela, you did that quickly. 3, 5, 2, 3, 1, 4. I'm just arrowing down and doing all my X's first because I feel like that's easier. 3, 2, 0, 10, 7. Okay. Does everyone have your tables built? Okay, so the next thing that we're going to do, is, do you see like box number 2? This is going to be a linear regression. Okay, we want to do a linear regression here. So we have to type in a linear equation. And remember, linear equations are in the form y equals mx plus b. So we're going to do y, and then I want you to hit the 1, y1, because this is a linear regression. So y sub 1, and it'll automatically pop a 1 down there. And then if you use the little, if anyone's in Spanish, the little tilde sign, the little Spanish tilde, which is like the little about symbol, if you hit shift and it's right below your escape button. Do you guys see that little symbol? Yes or no? Shift, and then it's right below the escape button on your computer. And then we're going to do A, X1 plus B. Maybe over in your notes. So I'm going to go to notes really fast. I'm going to write y sub 1 is about a x sub 1 plus b, and I'm going to write Desmos here. So that's like how I get the linear regression to pop up in my Desmos. Ma'am. Can I look? So you have y equals, and I don't want that. You need to do y1 and then shift escape. You see that? And then a little extra. There you go. Who else has a question? You see that? Okay. All right. So when we do that in Desmos, we get a little box that pops up that says R1. What is our R? Do you guys see it? What does it say R is? R, so let's write this down. R equals negative 0.914. So I'm going to go back to my notes, and I'm going to write that R equals 0.914, and it's negative, which means that this is going to be linear, right? Yes, it's linear because it has a strong negative correlation. So before I write the equation to the line of best fit, I want to show you where to find that. So the first thing I'm going to do is hit plot. Do you guys see this little button here, plot? This will plot your points that you just input. If I hit the magnifying glass at the table, where's that? This right here? Oh, zoom fit. You're amazing. Look at that. Okay, so the blue dots are your points that we just plotted. The blue dots are the points that we just plotted. Do you guys see the parameters right here? The A value and the B value? In our equation, y is ax plus b. So the A is really your what? Slope. So let's write that equation. So in our notes, our linear equation is y equals, our A value is negative 73.07 x plus 650.269. So I'm going to go to my notes and I'm going to write that my equation is y equals my A value, which was negative 73.07 x plus 650.269. So what is the slope of the line? Well, my slope is this value right here, negative 73.07. What does that slope represent? Well, it shows me that what? That the cost of repairs is what's it saying that the cost of repairs are doing? They're decreasing. Who said that? Good job. Get a piece of candy. The cost of repairs are decreasing, right? We're talking about cost of repairs. If it was positive, that would mean they were increasing. It's negative, so that means they're decreasing. Find the x and the y intercepts. Find the x and the y intercepts. Well, we can do that right from our table. We can do that right from our table. I know that the x-intercept happens when y equals 0, and the y-intercept happens when x equals 0. So here are your two intercepts. Do you guys see that? So the x-intercept is the ordered pair 10, 0, and the y-intercept is the ordered pair 0, 600. So if I have 0 oil changes, it's going to cost me $600. If I have 10 oil changes, it's going to cost me $0. So the more oil changes I have, the less expensive it is. Maybe they're on some like bonus program. Who knows? Okay. Use the equation to predict if the car had 4 oil changes. So I know that if I have 4 oil changes, it should cost me about how much? Or what? There are 2 4s in that table. Yeah, so that's why we have to use our equation. So let's go to our equation. Our equation is y equals negative 73.07 x, which is 4, because we're using 4 oil changes, plus 650.269. So we're just using our equation, and we're plugging in x for that value. So on my calculator, negative 73.07 times 4 plus 650.269 is $357. Did someone else calculate that? 357. I'm going to round to 357.99. Does that make sense? Okay. Remember that our table is showing us the values that like this person paid 400, this person paid 250. So it's doing an approximation or like the best fit between those 2 points. Okay. 250 to 400 is a difference of 150. If I were to take 150 and split it in half, I get 75. 250 plus 75 is about 325. So I'm close, right? Does that make sense? It's close to the data. Okay. Now we have another one that we need to build. we're going to do another one. So I want you to go back to Desmos. And we're going to do this table. This is a big data set. So I'm going to, you should be able to save these. Oh. So I'm going to add a new. I'm trying to get rid of this. I don't remember how to do that. What did you hit? What am I hitting? I got you. Thank you. Thank you so much. It was shrunk up. I couldn't see that. So we're going to add another table. And I'm going to put in my X's first. Once you get your table input, remember you're doing Y1, the little squiggly about. Yeah. Say again. Oh, yeah. But remember that, so that just means that it's probably going to have a really strong correlation, right? If there's only one point that doesn't follow the pattern, it's probably going to have a really strong correlation. So Y1, shift right below the escape button, AX1 plus B. And that gives you your equation. So I'm going to hit the little magnifying glass button. So I'm going to write my equation. Let's see. Does this have a strong positive, strong negative? What kind of correlation is going on here? Has negative correlation. And the correlation coefficient is negative 0.88. I know it's got more numbers, but that's fine. What's your equation going to be? Based off of this little table right here, what's my equation going to be? Yeah, let's just do 3 decimal places. Are you guys okay with that? Y equals negative 0.124x plus 12 point. If I just do 3 decimal places, I'm going to make that 629. Is that okay? 12.629. Okay. So I'm going to put that, I'm going to go back to the notes so you guys can see that. So I wrote that this has negative correlation. I wrote down what my R is, 0.88, and it's negative. And then I said my equation is Y equals negative 0.124x plus 12.629. So positive, negative, or no association between the bike weight and the jump height. Well, there's a negative association, right? Or negative correlation. Meaning, this is your X, as the weight gets bigger, the Y value, the height gets smaller. It says find the slope or the rate of change. Well, we know that the slope is the negative 0.124, which we rounded. What does this mean in words? It means that the height decreases by 0.124 inches per pound of bike, because that is what our units are given to us. Weight in the bike in pounds, height in inches. Remember, this is the representing, you do your inches first. So the height decreases by 0.124. That's why I didn't write it negative, because decrease means it's going down, by 0.124 inches per pound of bike. So the last question says predict, I know that that's crammed in together with the next one. Predict the maximum height for a bike that weighs 21.5 pounds. So this is my X value. So Y equals negative 0.124 times 21.5 plus 12.629. So I'm going to put that into my calculator to figure out my maximum height. If someone else has already done that, that's awesome. 124 times 21.5 plus 12.629. So I get that my maximum height is 9.963 inches. I know that's all crammed in together. That looks horrible. Does that make sense? Okay. So let's divide and conquer. We're going to divide and conquer. Miles, you and 7 other people are going to do example number 5. Okay. So if you want to do example number 5, jump on Miles' team. Jordis, you and 7 other people are going to do example number 6. Okay. Rosie, you and 7 other people are going to do example number 7. Okay. Just pick a table. I don't care which one. Pick a table and input it. Pick a table and input it into your Desmos. Pick a table and input it. Okay. I'm going to wait on you guys to answer the questions. So here's what we need. I want you to input your table. We're going to need the equation for each table. You are determining the equation. You are going to determine the equation. Pick a table. They all have the same amount of data points, so you're not cheating if you pick one with a smaller amount of data. They all have the same amount of points. So pick one. I need the equation. Miles, you're in charge of an equation. Forrest, you're in charge of an equation. And Rosie, you're in charge.
Wow, guys, so good. We got a whole group here.
You got it.
Okay, guys. I got it.
I need the equation for each one so we can answer questions. I need the equation for each one.
This one. Predict the weight of a. How do you do that? What is?
I thought dog years were 7 to human, like one dog year is 7 human. It says 15 on here. That's bogus. That it's bogus. Sometimes I feel like that as well.
5'8" plus. What do we plus it? Oh.
I think you guys are doing fabulous. We're needing some equations.
No, literally. Why are we? What are we doing?
We're checking our answers.
Okay, I got 55.9. Where did you get that? Where did you get that? And then you get y1 in the little symbol. What is x1 plus b? And then Okay.
She's right. Listen to her. Miles, you got an equation for us? No? Okay. Okay. That's all I need.
I literally got that.
Which one are you guys doing? Okay.
Yeah, we got the numbers there.
The first number is this one. So it'll be y equals that x minus.
So you can get something different.
And then we plug it in. And then we divide. We multiply.
So what did you get?
I don't know.
1.705
from like your answer.
I
Oh wait, did you multiply it already?
What's your heat? You did that for me.
Yeah. Yeah. Oh, you were talking about that equation.
Okay. Did you have a question for me? Yes, go. Yes. I love your outfit. Okay.
Oh my god.
Who's got an equation for me? Jasmine, what table did you guys do? Table number 1. What equation did you get? Y equals 5.036 x plus 12. Got it. I'm putting it up there and I'll save it for a second. Okay. So how many years is comparable to 12 dog years? That means I'm going to take that equation, y equals 5.036 times 12 plus 12. You calculate that for me and let me know what you get. For what? So 72.433. Got it. Perfect. Example, our table number 2, games and rushing yards. Who's that table? Table number 2. What'd you guys get, Lainey, for your equation? Do we have a table input at all? Okay, so y equals, what's the a value on your table? I didn't hear you. Negative what? So negative 21.036 x plus, what's your b value? 714. Okay. So predict the number of yards in the 10th game. So that means I'm taking my equation y equals negative 21.036 times 10 plus 376.714. What did we get for that? Is someone calculating that? Negative 21. It should be like 165, close to 165. Is anyone calculating that, or do I need to pick up a calculator? Everyone's looking at me like I have. What'd you get? Okay.
I got 587.07.
Okay, you forgot to make that negative because I got about 166. It's about 166 yards. Okay. The second question for that table says, in which game can the team expect to get only 100 yards? How do I do that? What is that 100 yards representing? The X value or the? It's representing the Y. So I replace, oops, poop on a stick, sorry. I replace the Y value with 100. So 100 equals negative 21.036x plus 376.714. So 100 minus 376.714 And I'm going to take that and divide it by the negative 21.036. And I find out that they can expect to only get 100 yards in the 13th game. So it sounds like the other teams are getting better and they're getting worse. I don't know. Maybe other people are injured. Who knows? Okay, who had the last table? Okay, last table. Give me the equation.
1.7
Y equals
y equals 1.705x
705?
Yeah.
705x. Keep going, sorry. Minus, 42.95. Okay. So this says predict the weight of a 58-foot whale. That means let x equal 58. So y equals 1.705 times 58 minus 42.95 in tons. What is the weight of my whale? 55.93 tons. Holy moly. Okay. What do you think? I'm going to leave those up there so you guys can show that. We still have 3 more examples to do before I get you on your homework. 3 more examples to do. Ma'am, there's 2 people out. Can you wait till one of them comes back? Either Violet or Naomi. When one of them comes, you can go. Okay? Oh, Violet's back. Okay, go. Sorry, Violet, I didn't see you. I apologize. So write that down so we can do our last 3 examples. Write it down, write it down.